Good morning, dear students. My name is Ferhan Mazher, and today is 20th November 2020. And right now, I am with the 10 Cambridge boys. And today, uh, we have uh, chosen a worksheet that is about light. This worksheet I have taken from a website. The name of the website is savemyexam.co.uk. And we have on the last Friday, we have already worked on this worksheet. Last Friday, we were able to complete 15 MCQs of this worksheet. And today, now we are again started working on it. So now in this lecture, this video, we will be starting from the question number 16. So let's go to question number 16 and let's see what we have here. Okay, so we are going to question number 16. Last time we were done with question number 15. Now, here we go. Which row applies to a short-sighted eye viewing a distant object? Okay. Position: short-sighted person can see the near objects, but is not able to see the faraway objects. So the basic thing which goes wrong with the lens is that the lens will be focusing too much. It will be bending the light too much. So when it bends the light too much, so what happens? It starts making the image in front of the retina. It starts making image in front of the retina. To correct this problem, we use a diverging lens. So D will be the right answer. I think that the D is the right answer because the position of the image is in front of the retina. The eye is bending the light too much. So for that purpose, we use a diverging lens. That's the short-sighted eye. So D is the choice. Good question. A shoe shop puts a mirror on the wall so that the customer can look at their shoes. The length of the mirror is 50 centimeter. A customer has eyes 150 centimeter above the ground. The bottom of the mirror is at height h above the ground. What is the smallest value of h that allows the customer to see an image of his shoe in the mirror? Okay, so let me take this to the thing so I can work on it. I'm skipping to okay. So let me copy this. I'll take it to the page. You work on it. This is the question on your screen. So what you will do, first of all, what is the middle point of this boy? This boy's eyes are 150. So approximately this is okay. Okay. Now this height This height is half of the 150, that is 75. Okay. So if you want that the light rays from here, they come here and they go. Let me show you. Okay. You want the light rays to start from here. They will come here. And from here, they will go into the boy's eye. Okay. Now, the mirror, this mirror here, if you move this mirror down, 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 this tip of the mirror, if it's present here, if this top corner of the mirror is present at this point, if you move the mirror down, if this top corner is here, the boy will be able to see his. Okay. If you move this mirror down, this top corner, if it comes here, even then the boy will be able to see him. Okay. When you make the top of the mirror, okay, if the mirror is here, like here, okay, the mirror is 50 centimeters. So this height will be then how much? This total is 75. If the whole mirror it goes down until the tip of the top of the mirror is here, the mirror, because it's 50, so this thing will be how much? It will be 25. It will be how much? It will be 25. This will be 25. Okay. So this will be 25. It's a very tricky question. The very, very tricky question. So the height, if you move the whole mirror down, but the tip of the top of the mirror should be here, so that the light from here can be reflected into the eyes of the boy. So the boy will be able to see his shoes. This point is 75 centimeter high. If the mirror is down here, the mirror is 50. So this height will be only 25. So 25 is the right answer. So his question was, what is the smallest value of age that allows the customer to see an image of his shoes in the mirror? That will be 25. So B is the answer. 25 centimeters. So B will be the answer. Okay. Let's go to the next question. The diagram. The diagram shows light traveling through a medium. The light reaches the boundary, but with a vacuum as shown. The light emerges traveling along the surface. What is the refractive index of the medium? What is the refractive index of the medium? Okay. So refractive index of the medium, you see, we can, let me take it to the other sweeping tools. Let me take this diagram to that place, into the paint. one. Don't save. Let's get a new one. Okay, here we go. So let me draw a normal here. The normal is something which makes 90-degree angle with the surface of the, okay, this red color line represents normal. Okay, so the angle of incidence is this one. The angle of incidence is how much? 30. This is the angle of incidence in the dense medium. This is the angle of incidence. And the angle of refraction is this. This is how much? It's 90 degree. Okay. So we can find the refractive index. The formula is N is equals to sine of the sine R. It's very difficult to write with this in the paint with the mouse. Sine R divided by sine I. Snell's law. It's sine R divided by sine I. So it should be sine 90 divided by sine 30. It should be sine 90 divided by sine 30. Sine 90 divided by sine 30. So let's check. Let's check. Do we have this option? Sine 90 divided by sine 30. So C is the right choice. C is the right choice. See, these questions are a bit tricky. Sine 90 divided by sine 30. So the diagram shows an object on the principal axis of a converging lens. A principal focus of the lens is at F. Where is the image formed by the lens? Okay. So let's copy this. Copy this, take it to the paint, and we will work on it. See how we get the answer. I will take it to the paint. Yes. Okay. Here we have that. Okay. Now, if you want to locate the image, we use two rays, and these rays starts from the head of the object, and it moves parallel to the principal axis, and then from that point where it is in the lens, that point it passes from the F. It passes from the F. So here you go. Okay. The second ray also starts from the head of the the object, and it passes from the optical center. Let me do. It starts from the head of the object, passes through the optical center. So you will be able to see the image here. you will be able to see the image here. Here you will see this will be. Here will be this green, dark green color line that represents the image. So this is F. This is 2F. So it's beyond 2F. It's beyond 2F. Okay. So let's see the options. I hope you have understand. We have located the image actually on the diagram. And now we will see what are the options we have. He says between O and F. That's wrong. Between F and Q. Where is Q? Q is not written. Principal, okay. At Q and to the right of the Q. I think something is missing here. I think here the Q is written. So here I think he was supposed to write Q. So it will be on the right of the Q. Okay. The diagram shows an object on the principal axis of a converting lens. The principal focus of the lens is at F. So you see in this diagram it's missing this labeling Q. So it should be here written Q. So the image, this is F, this will be 2F, the Q, and this should be at the right side of the 2F or the right side of the Q. I hope there is Q written. Something is missing in this question. Okay. A digital camera uses a lens to produce a diminished, reduced in size image on a light sensor. Which row shows the correct type of lens and the nature of the image? The lens is converting lens. In the camera, we use converting lens, and the image is real. The image is real. A digital camera uses a lens to diminished. Okay, the image is real, and the type of the lens is converging. The image will be inverted. So A looks the right answer. A looks the good answer. Type of lens is converging. Nature of the image is inverted. A plastic tube is immersed in a liquid of refractive index 1.4. Light traveling in the plastic tube strikes the inside surface at an angle of incidence of 70. The light undergoes total internal reflection. What describes the value of the critical angle in the plastic and the refractive index of the plastic? Okay. This is a plastic tube. Most probably it's optical fiber. In the optical fiber, this inner core has higher refractive index as compared to this outer material. This inner material should have, this plastic tube should have, the plastic tube should have, more refractive index as compared to the outer layer. Okay. So what we will do, so the refractive index of the plastic should be greater than 1.4. And what about the angle of incidence? The critical angle, because the light has gone under the total internal reflection, because the light is undergoing total internal reflection. So this angle of incidence is more than its critical angle. So the angle of incidence should be less than 70. So the critical angle in the plastic is less than 70, and its refractive index is its refractive index is more than 1.4. So I hope that this is clear to you. This was question number 21. So the C is the right choice. For question number 21, C is the right choice. I hope that you have understood, and I hope that this is clear to you. Okay, so we move to the next question. Question number is 22. Which characteristic which characteristics describe an image formed by a vertical plane mirror? The image which is formed in the vertical plane mirror is virtual, it is upright, and it has the same size as that of the object. Virtual, it's virtual and not inverted. It's virtual and not inverted. This is the answer. Virtual and not inverted. Okay. So next question, question number 23 is on your screen. A ray of light meets the face of a glass block at an angle of 30 degrees as shown. The refractive index of the glass is 1.5. What is the angle of refraction inside the glass block? Okay, let's me take this diagram. Slipping tools we use. I copy from here. The refractive index of the glass block is 1.5. Okay. Let me take this diagram into the paint. Let's see what. Okay. Yeah. So you know n is equals to sine I by sine r. This will be the angle of incidence, and this is how much? This will be 60. So the angle of is 60 degrees. So the angle of incidence will be 60 degrees. So then I will apply that formula. N is equals to sine, and the n value is 1.5. Refractive index value is 1.5. Is equals to sine I. That will be sine of 60. That will be sine of 60 divided by sine R. So what I will do, I will take out my calculator. So let's try. I don't have the scientific calculator right now with me. Let's try it and do it. So I will write sine 60, sine of 60. Sine 60 is 0.866. It is 0.8 divided by 1.5. And I will come here. Sin R. Sin R. So let's check what is the answer of 0.866. 0.866 divided by 1.5. So the answer is 0.77. 0.77. 0.577. it will be 0.5, 7, and 7. So then when I will make this R alone, when I will make this R alone, the sign will go on the other side and it will become sine inverse. So I will take the sine inverse of 0.577 inverse. So the answer is 35. 35 is the answer. Approximately 35. Okay. So you can do this on the calculator, your calculators. So 35 is the answer. So let's check. Do we have this option? 35. Yeah, we have this option here. So C will be the right answer. That's question number 23. Okay. So next question. The diagram shows a thin converging lens of focal length F. Where must an object be placed to produce a real image in the position shown? Okay. Let's copy this and take it to the paint. We can work on it actually. And let's see what happens. Okay. Do this color. So there are two methods. Image. So from the tip of the image, a light ray will start, which will pass through the. We are going in the reverse, okay? We have the image, we want to locate the object. So I will start from the tip of the top of that arrowhead of the image, and I will start a ray from there. It will pass through the optical center and it goes undeviated. Then I will start a ray from here and it should go past from the optical F. Okay. From that point, I will from here. Then the light ray moves parallel to the principal axis. The object, I think, will be here. The object, I think, the object is here. This is the object. This is at the position A. So you see, you understand this, how I work on this. This is actually, you have to work on it with a pencil and a scale. So at the position A, the object should be placed. At position A, the object should be placed. So A is the right answer. This is the answer. You understand this question? Okay. Question number 25 is on our screen. Which diagram represents the reflection of light along an optical fiber? In an optical fiber, the light is undergoing total internal reflection. So you have to carefully choose that where the correct total internal reflection is taking place. When the total internal reflection takes place, the angle of incidence and angle of reflection, they both are equal. So let's copy from here, and it's easy. You might be able to answer directly by looking at them, but let me show you how exactly we will get the answer. Copy from here. Let's paint it in the paint. Okay. One. Here. Here. So I will draw normal. When I will draw a normal blue color normal. See, when I draw normal, the angle of incidence and angle of reflection clearly are not equal to each other. Okay, let's try to draw normal here. Okay, it looks little better. The angle of incidence and angle of reflection looks equal to each other. It looks easy. Let's draw here. You see, the angle of incidence is smaller and the angle of reflection is larger. So C cannot be the answer. If I draw a normal here, even here the angle of incidence is greater and angle of reflection is smaller, so it's wrong. So the only better option is B, where the angle, when I draw normal there, the angle of incidence and angle of reflection, they are equal to each other. So B looks the best option. So I hope that you have understood that how we decided that which diagram is showing the correct total internal reflection process. So B looks the right answer. So looks B is the right answer. B is the right answer. Okay. The diagram shows rays of light. What is the space labeled as? You see, there are parallel rays of light and they pass through this, whatever this is, X, and then they diverge. The one light ray which passes through the center of the body, optical center, goes undeviated. The rest has diverged. So it's a diverging length. What is in the space labeled X? It's a diverging length. Very simple. It's a diverging length. A ray of red light from a laser passes into a semicircular glass block. What is shown at M? You see, at M, the refraction of light is taking place. Refraction. The word is refraction. This is happening. D is the right answer. The refraction of the light is taking place. Refraction of the light is taking place. A ray of light strikes the surface of a glass block at an angle of incidence 45 degrees. The refractive index of the glass is 1.8. What is the angle of refraction inside the block? Okay, so we can, let me show you how we do this. Let me take a sheet. Okay. The formula is very simple. The refractive index is N equals to sin I divided by sin R. You know, in the denominator we always put that angle which is in the air or which is in the rare medium. So let me see the diagram again. Inside the block. Okay. So the angle of incidence, he said that the angle with the surface of the glass block and angle of incidence of 45 and the refractive index is 1. The refractive index is 1.8. So it is value is 1.8. 1.8 is equals to sine I, that's sine 45, sine 45 divided by sine R. Okay. So sine 45, let's see what its value is. Uh, uh, okay, so we will go sine of the 45. So 45 and its sine. That is 0.70. 0.70 divided by 0.70. 0.70. 0.707. Okay. 0.707. And then I will divide it by the 1.8. Very difficult to write here. I don't have that. 8. Okay. I will enter this value on the calculator and let's see. So I will divide it with 1.8. So that is 0.39. Then I will take its sine inverse. So the answer is 23 degree. So the answer is 23 degree. So the angle of refraction will be 23 degree. So A is the choice. A is the right choice. Okay. Let's see the question. Light is incident on a mirror and is reflected as shown. What is the angle of incidence and angle of reflection? What is the angle of incidence and angle of reflection? Let me copy this and take it to the paint so you can understand this how actually we work. The question is, what is the angle of incidence and angle of reflection? Let us bring it here. Okay. This whole angle will be 100. If you remember mathematics, this is a straight line. This portion is 80, so this portion will be 100. This angle of incidence and angle of reflection, they both are equal to each other. So their values should be 50-50. If this is 50, this should also be 50. Because the angle of incidence and angle of reflection, they both are equal to each other. This whole angle is 100. This is angle of incidence, angle of reflection. So 100 divided by 2, 50. So the angle of incidence will be 50. The angle of reflection will be 50. So D is the right answer. D is the right answer. So next question, which is question number. Light is incident on one face of a glass block at an angle of incidence of 40. The glass block is in the air. The refractive index of the glass is 1.46. What is the angle of refraction inside the glass block? Okay, let me do this on the calculator. Without going into the paint, let us do this one. Okay. Okay. Now, the formula for the refractive index is N is equals to sine I divided by sine R. N is equals to sine I divided by sine R. When we put the values, it will be 1.46 equals to sine 40 divided by sine R. So let's find out what is the value of the sine 40. So 40, it's sine, and then you have to divide it with the refractive index, that is 1.46. So this is the answer. Then when I will make the R alone, the sine will come to this side and it will become sine inverse. So I will take the sine inverse of this thing. The answer is 26.1. So A is the right answer. A is the right answer. So that's it, G, for today. We were working on the worksheet. This worksheet is related with the light, and this is the second video on this worksheet. You see, it takes longer time as compared to the other topics when we work on the topic of light. So in our first video, we did 15 MCQs, and today we are able to complete 15 MCQs. Today we started from question number 16, and we are done till question number 30. Today we have done 15 MCQs. So still there are questions in this worksheet. I think there are a lot of questions. Totally there are 70 questions. So we will try to complete this worksheet in our next few days. So in this video, I think it's enough for today. So this worksheet I have taken from a website. The name of the website is savemyexam.co.uk. My name is Ferhan Mazher, and I was with the 10th Cambridge class. Today is 20th November 2020. The subject we were studying was Physics 5054. And we have done the MCQs on the topic of light. So, Ji, thank you very much, everybody. Have a good day, and God bless you all. And enjoy your life. Bye-bye.